Okay. So now we need 1 lead ion, 2 chlorine ions. So when we write this, hey guys, write notes. Is this when we do lead 2 chloride? Guys, check your work. All right, so lead 2 chloride. Potassium and sulfur, if we have one that has a +1 charge and one with a -2 charge, we're going to need 2 potassiums and 1 sulfur. K2S, potassium, sulfide, tin and fluoride. 1 tin, 2 fluorides.
How do you? Oh, never mind. I felt a little like. I was like, how did you know that?
Tin 2. So the Roman numeral number is telling us something about the charge. Did I spell fluoride right?
Yeah, I think you're supposed to. No, I don't think you're a U.
No, that's it. That's right.
Is there?
Yeah.
I always kind of get stuck if it should be OU or
I think it's OU.
UO. Anyway, barium iodide we already did. Now we're being given. It's UO. All right, next we've got aluminum and chlorine. Chlorine's got a -1 charge. We're gonna need 3 of them, and aluminum has a +3 charge. Name of it is aluminum. What do they call aluminum in England?
Aluminium.
Aluminium. That is correct.
But like with an accent. With a Spanish.
No, it's just got an extra I in it. Nitrate. What charge does nitrate have?
-1.
We're gonna need 2 of them. You guys are good at this ion now, right?
Why did I think that was silver? So why you brought up
I don't know. We did silver nitrate on our experiment. All right, what'd you guys do with this one? It does have potassium. Okay, do you guys see that this is 1 ion? What's it called? Acetate. But over here I'm going to write C2H3O2. Acetate. Yeah, acetate. Don't say it too fast. Okay. Next one. We've got 2 NH4s. What's our charge for NH4? It's +1. And SO3. Sulfite? Sulfate?
I have no idea.
Sulfate's SO4.
Oh, so sulfite.
Yeah.
Aha, I was right the first
I
time.
had my first answer. Then
Ammonium sulfite. Easy peasy lemon squeezy.
This should just be what's on the test.
Just this?
Yeah. And then.
I could make them hard.
Like this silver knowledge.
Silver is Ag, which is a +1. Oxide is a -2.
look at me.
So if we've got Ag +1 and O -2, how do we balance it? We're gonna need 2 of the Ags. Yeah. Iron 3 sulfide. So this is telling us that the charge of our ion is +3. And then we have sulfide. What's sulfide?
Or -2.
Yeah, it's the same as oxygen.
I think 2.
How many of each do we need?
2 iron, 3 sulfide.
Yeah. Iron sulfide is also what mineral? No. Rust is always iron with oxygen. Iron with sulfur. You guys know what color sulfur is?
Yellow.
Yellow. What is a metallic yellow mineral? Yeah, but gold is made out of gold. It's pyrite. How'd you guys know it's pyrite? I did say it before.
Boom! Good memory.
Yeah, we learned stuff.
Also, I learned it from kids shows. PBS,
Yeah,
PBS taught me everything I know now, honestly.
they kind of
Taught me math, taught me how to be nice.
They kind of bash pyrite in your head.
Literally.
I watched a lot of Where in the World is Carmen Sandiego as a kid. So I have like a shocking memory of like landmarks. All right, magnesium chloride. What's the charge of a magnesium ion? It is +2. Same as what? Something that's in the same column.
I don't know. Aluminium?
No, I was thinking calcium.
Oh.
Chloride has what charge? -1. How many chlorines do we need for every magnesium? 2. Magnesium chloride. Calcium carbonate. Ooh, that's one of my favorites. What mineral is calcium carbonate?
I don't know. Is that the one that you can't eat?
No, you can't eat it. You can eat
You
it.
can't?
Yeah. I wouldn't because of impurities, but
Okay, I was gonna say, like,
yeah, people actually used to eat it. They used to use it to treat stomach upset. Like they would use it the way we use Tums.
Tums are kind of gross.
You'd like make a slurry with it. All right, so the mineral name is calcite. It's the same mineral that you find. It's the same mineral that you find inside caves that form stalactites and stalagmites. If you ask for a rock type, what rock type is calcium carbonate?
Or,
There's actually 2. There's a sedimentary rock and there's a metamorphic rock. Anybody?
oh, this is like 5th grade. I don't remember.
No, this is really academic team stuff.
Oh, I need it.
Anybody on academic team? You should be. It's fun. Okay. Rock types would be limestone
I love that for you, Charlie.
or marble.
I'm not good at all. I keep forgetting every week how to make stuff.
You guys with me?
Yeah.
If I think you guys don't want to pay attention anymore, maybe we will have a quiz instead of just going over it.
No.
I'm not good at doing stuff.
I think I did that wrong.
I've reached teaching by threatening quizzes.
No,
That is not fun.
Focus, kids, or there will be quizzes.
I'm doing
Have you ever done that? Like, were you giving them a quiz?
Oh yeah.
Really?
I guess.
Oh boy.
I've also lectured as punishment.
Okay, but like, you lecture what?
Well,
Yeah, the way you
generally,
lecture,
so
you
this
don't
is
rant,
this
so
is
then-
a weird year. Normally, you guys would be doing more activities and stuff. And so I had one group of kids, and they were like, "Oh, another activity? Can't you just lecture?" And I was like, "Sure." By the time I was done with that lecture, they were like, "Can we please?" It was long and like very detailed. Can we please go back to activities? Sure. All right, so we've got a magnesium with a +2 ion and a nitrite, I believe. Nitrite with a -1. I think we're gonna need 2 of those with our 1 magnesium. We're gonna end up with magnesium nitrite. I think that's nitrite, right? Charmaine, you would tell me if it wasn't.
Oh, yeah. I remember it because nitrate A is bigger than I.
Whatever works for
Bigger
you.
than 2.
That falls apart though with some of the other ones, like
I only memorized
chromate,
nitrate.
sulfate, sulfite. Like anyway. Copper and hydroxide. This is actually a compound that I make when I get rid of those blue liquids. We get some sodium hydroxide and we precipitate out copper hydroxide, which is also pretty. When I do that, I'll show you guys. It's nice looking. So we end up with copper 2. Do we need copper 2? Copper 2. Hydroxide. Why did I put that there? That doesn't need to be there. It's over here. That's why it looked funny. Last one. You guys think of this one? I just think it looks funny.
I think it's.
Potassium is a +1 charge. We've got 2 of them. We also have a CrO4. What's the name of CrO4, guys? Whoa.
I got
Chromate.
Chromate? Oh, wait.
Oxalate's different.
Oh,
Yeah.
Oh, oxalates with carbon. That's why.
Gotcha. All right, you guys have any questions? How do you guys feel about empirical formulas and names and stuff? You remember how to do it? Good, I'm glad. So we've got another reaction here. We're not going to do that yet, at least. We'll see. Well, yeah. I mean, and this is kind of similar to what we already did. So here's what we're going to do. We're going to try samples of every kind of problem. You guys ready?
No.
Haha, this will be good. All right. So it says write a complete solution to each of the problems below. Follow the procedure outlined in class. Be sure to circle your final answer. I know. All right. So
I think I can be number one.
okay. Don't worry, it's going to get worse later.
I'm sure it is.
So what we're going to need to do is we're going to need to write our equation, our before, our change, and our after stuff. So it says calculate the number of moles of potassium chlorate that must decompose to produce potassium chloride and 1.8 moles of oxygen gas. So the first thing we have to do is figure out who our major players are. So we're going to start with KClO3, and it's going to decompose. What kind of reaction is that? Yeah, decomposition reaction. Dr. O'Malley asks is a hard one. And oxygen gas. And I'm kind of like trying to make it a little bit shorter so that I have more scratch paper space. Is this balanced? No. We're going to need, whenever I see 2 and 3, I just kind of switch them. I put a 3 here and a 2 over here, and usually that makes it work. Right? Because then my oxygens work out. Now I need 2 of these guys. Boop, like that. Now, we're going to start with something and get products. It doesn't say that we're starting with any of the products. And so we're going to say, okay, hold on, I'm going to draw a line here. We're going to say, okay, we've got 0 moles of each of those products to start with. But it says that we produce 1.8 moles of oxygen gas. So down here, we're going to need to produce 1.8 moles, which means we pick up 1.8 moles here. What are we going to do, guys? Firstly, aren't you happy that you don't have to convert anything to moles? Yay! And it even asks us for moles in our answer, so yay! All right, so if I've got 1.8 moles of oxygen, I'm going to use my stoichiometric coefficients to figure out how much potassium chlorate I'm going to need. So for every 3 moles of O2 that I produce, I'm going to need 2 moles of potassium chlorate. Calculator friend. I got my daughter a pink calculator, and she's like, Mom, I don't like pink. And I was like, no one will steal your calculator. It's the best choice. It was 3.6. Okay, 3.6 divided by 3. I'm going to need 1.2 moles of potassium chlorate. Does that make sense? Does that seem reasonable as an answer? I think that it does. Because it should be less than this one, right? And the ratio of those two, should be 2 to 3. So is 2 to 3 the same ratio as 1.2 to 1.8? Yeah. And I could confirm that. So if any of you out there are not believers about this, I could go 2 divided by 3, and I would get 0.6666667. Or I could do 1.2 divided by 1.8 and get 0.666. So I get the same number. And so that's how I can confirm that the same ratio. Just like giving away all the punchlines. All right, so that's the answer that we're trying to solve. We don't have to convert anything to grams or anything else. Yay. It says be sure to circle your final answer. Maybe I should circle final answer instead. Okay, so how much time do we have? We have like 5 minutes. So what we're going to do is work on this problems today and tomorrow. Okay, so our goal is that by tomorrow we finish this. Cool? It's not homework. Do you want homework?